I'm Mohapriya. Now we are going to see about threads in computing. A thread is the smallest unit of execution within a process. A process can have multiple threads running independently. Threads improve performance through the parallel execution. The characteristics of threads are lightweight compared to process, shared memory space within a process, faster context with switching, efficient resource utilization. Types of thread. User level threads managed by a user programs, not the operating system. Kernel level threads managed directly by the operating system. Single thread versus multi-threaded application. Single threaded, one task at a time. It does a one task at a one time. Example, old text editor. Multi-thread, it does multiple tasks running concurrently, like a web browser. Advantages of using thread: faster execution by the parallel processing, efficient CPU utilization, reduced memory consumption, suitable for real-time applications. The disadvantages of threads are synchronization complexity, debugging is difficult, context switching overhead, and risk of deadlocks. Thread lifecycle. New. Thread is created but not started. Runnable. Ready to run, waiting for CPU. Block. Waiting for a resource. Terminated. Execution completed. Thread synchronization. Prevent multiple threads from accessing shared data simultaneously. Race condition. Unpredictable results due to unsynchronized access. Mutex and CMOFO used to ensure proper synchronization. Threading models: many to one to one, many to many. In many to one, multiple user threads mapped to a single kernel thread. One to one, each user thread has corresponding kernel thread. And in many to many, many user threads mapped to multiple kernel threads. Multi-threading in programming languages. In Java, thread class and runnable interface. In Python, threading module. C and C++, POSIX threads, P threads. Example for Java multithreading. In a Java, the example Java multithreading program. Example for Python multithreading program. Real-world applications for threat. A web service handling multiple client requests. Gaming engines for smooth gameplay. Real-time systems like self-driving cars. Threat pooling. Threat pooling manages multiple threats efficiently, reduce threat creation overhead, used in web services and databases. Threat deadlocks occurs when two or more threads wait for each other indefinitely, leads to system freeze. Avoid using proper synchronization techniques. The performance optimization with threads. Load balancing for efficient execution, minimizing unnecessary thread creation, using thread pools to optimize resource allocations. Threads versus process. Threads share memory, process do not. Threads are faster, but process provide better security. Process can run independently while threads depend on a parent process. Challenges in multi-threading. Ensuring proper synchronization, debugging difficulties in concurrent execution, scalability issues when dealing with large number of threads. As a conclusion, threads improve performance through parallel execution. Require careful synchronization to avoid issues. Used in various real-world applications for efficiency. Thank you.